Howdy, today I'll be going over the Chapter 10 growth rate formula as well as the compounding formulas and the rule of 70 example. First, I'd like to start with the real GDP approach, which the formula for this is going to be the real GDP per capita of the current year minus the real GDP per capita of the previous year divided by the real GDP per capita of the previous year multiplied by 100. So here, if we're going to start in the year 2017, which will be our current year, we'll have 23, and then we'll subtract 12, which is the GDP of the previous year, and then we will divide by that same number. And 23 minus 12 is going to give us 11, and 11 over 12 is going to equal to 0.916. Multiply all this by 100, and that is going to give us a 91.6% growth rate. That's it, plain and simple right there. All you have to do is take your current year, subtract your previous year, divide by that same number as the previous year, and then multiply by 100 to get the percentage. Now, using the nominal formula, all we have to do is use the nominal GDP growth rate, subtract the inflation rate, and then subtract the population growth rate. So our nominal rate would be 12. We would subtract the inflation rate, which would be 3, and then we would also subtract the population growth rate, which is a -1, which this would be 9, and then since we're subtracting a negative, will give us 10. So 10% growth rate on the nominal side. Now, compounding is a little different. It's defined as the economic growth that builds on itself over time. So there are some variables that we don't know. However, there are variables that we do know that are going to help us get this answer. So this formula is going to be GDP of year B. So that's going to be 20,000 times 1, this in parentheses, plus the growth rate, which is 3 over 100. And calculating that is going to be 3 divided by 100, 0.3 plus 1 times 20,000, and I'm going to get 20,600. So that means that 600 of that came from the compound. And last but not least, the rule of 70. This is just how to calculate how many years until income doubles. So even though we have the real GDP per capita here, we don't really need this. We just need the growth rate part for the rule of 70. So the rule of 70 is kind of a constant. All you have to do is have 70 over whatever your growth rate is. So in this case, it's 6, which doing that is going to give us 11.6. So we will say 12, round up to 12. So it'll be 12 years until income doubles again. And now it's good to say that all of these have a relation. If you have your nominal numbers like you do here, and you have your inflation rate here, your population here, you can actually subtract these to find your real GDP per capita. And if you didn't have the numbers, you could actually plug that in to this table to find those. And that's about it. Pretty basic, simple formulas. I ran through it quick since I had the numbers there. However, you can work backwards and use algebra to find missing numbers in order to get these. Thank you.